Okay, let's start with this one. So the 3 doesn't have a pair. That's when you do the basis. So let's work with this using the properties of exponents. So you know that if they are divided, you need to subtract the exponents. So this is 3s to the 1 minus 1/3 t to the 2 minus 2/3. And that's because these are the exponents. There's a 1 there, a 1/3, a 2, and a 2/3. Then the next thing that you're going to do is you are going to, and I apologize, this is incorrect. This should be right here, should be 3/2. So I'm going to change that to 3/2. So what you're going to do is you're going to make this the same denominator as the one that you have. So you have 3s to the 3/3 minus 1/3, because 3/3 equals 1. And by the same token, t to the 4/2 minus 3/2, because you have a half here and a half here, and 4/2 equals 2. So you needed to be able to do that. And so your response should be 3s, and then 3 minus 1 is 2, and then t, 4 minus 3 is 1. And that's your response right there for this one. For this one, you're going to do the same thing we just did for the previous one. So you have 5g to the 5/3 minus 2/3, h to the 3/2 minus 1/2. Because again, remember that when you have an exponent, when you have an expression that has the same base, and you have the exponents, so these are the same bases, the g and the g, and the h and the h. Then you subtract the exponents. So now you have 5g, and this is 3/3, and h, and this is 2/2. Now 3/3 cancels out, 2/2 cancels out, so that's 1 and 1. So you have 5gh. Now in this case, the best thing to do is to rewrite this as an expression with exponents. So you have 4x minus 5 to the 1/2 equals x plus 7 to the 1/2. And the reason that's true is because a square root, this is inside the square root, and that's to the first power, and a square root has a 2 there that's never shown. So the numerator is inside, the denominator is outside. So you have to the 1/2. Now, in order to get rid of that 1/2, because I need to, in order to be able to solve for x, I'm going to have to raise this to the second power. And whatever I do to one side, I do to the other. And 1/2 to the second power is 1, because 1/2 times 2 equals 2/2. Same thing happens to the other side. So now I end up with an equation that you know how to solve, which is 4x minus 5 equals x plus 7. And then you subtract x from both sides, and you have 3x minus 5 equals 7, and you add 5 on both sides, and you have that 3x equals 12, divide by 3, and you get that x equals 4. Now before you do anything on this one, you want to make sure that you have this one on that side. So what I'm going to do is I'm going to subtract this expression right here from the other side. That way, when I square, I don't have to FOIL anything. So I have the 4th root of 3x equals the opposite, so negative, the 4th root of x minus 7. And I am going to do the same thing I just did. I'm going to raise that to the 1/4, because that's what this means. And that equals negative x minus 7 to the 1/4. And in order to solve, I'm going to raise that to the 4th power. Actually, it's everything. So I'm going to raise both sides to the 4th power. And that should be this whole thing. So I'm going to raise that. And anything to the 4th power is going to give me a positive there. So I'm going to have 3x equals x minus 7. I'm going to subtract x from both sides. And 2x equals 7. And I get that x equals 7/2. Now the one thing that I need to check here is whether or not this is true. So I'm going to check 3 times 7/2 equals, and that's 21 over 2. And then if I substitute that also here, I get, so this is the fourth root of 21 over 2. And I'm going to try that there. So I'm going to do I apologize. This should be 7 over 2. So 7 over 2 minus 7. And that's going to give me, this is over 2, so 7 over 2 is 14. This is going to be minus 7 over 2. Now, notice that this doesn't work, equals 0. And that's actually going to be true no matter what xi value I use. And that's because if you think about it, no fourth root is going to be negative ever. So no matter what I add, well, actually it could be, but no matter what I add here, depending on my x value, if I use a positive x, like 7/2, 7/2 is less than 7, this is not going to be a real number. So right now 7/2 doesn't work. So this wouldn't be the solution. So in this case, there's actually no real way to do this. So there's no real solution. Oops, sorry about that. So no real solution is your answer here. Because if I substitute that 7/2 in there, I get a negative. And you know that if I have a negative in an even, I would have an imaginary number. And again, you know that that's not possible here because whatever I add here to this, I'm not going to get 0. There's no way to get 0 on this problem. Now for this problem, again, I'm going to write this with exponents. This is 1/2 of x to the 1/2. This is the only one that has an exponent. So in this case, I am going to raise this to the second power, but I now have to raise this to the second power. Now this one right here didn't have an exponent originally. So now I have to FOIL. So I have to do x squared minus 1/2 x minus 1/2 x, and that's how you FOIL. So if you need to check the FOIL, please make sure that you do, equals 1/2 of x, because that cancels out. So this is minus 2/2 x, so this is x squared minus x plus 1/4 equals 1/2 of x. Now I'm going to move that x to this side, so I'm going to subtract 1/2 of x from there, so I get x squared, and if I have minus x minus 1/2 x, this one is the same as minus 2/2 x, right? So minus 1/2 x, that gives me minus 3/2 of x. So then I have x squared over here again, x squared minus 3/2 x plus 1/4 equals 0. And to be able to do the rest of this problem, all you really have to do is you want to use the quadratic formula. So your a equals 1, b equals negative 3/2, and c equals 1/4. And you use the formula the opposite of b, so you use, sorry about that, the opposite of b plus minus the square root of b squared minus 4ac over 2a to solve for x. And then when you get those x's, make sure you substitute them into this original equation over here to see that they work. If they don't, they're not a solution. Because remember that one of the things in this section is that you can have an extraneous solution. And if you do have an extraneous solution, you cannot use it. This is a similar problem from before. So again, this is 44 minus 2x to the 1/2 equals x minus 10. So you're going to raise that to the second power and raise this to the second power. And you get 44 minus 2x equals x squared minus 20x plus 100. You're going to subtract 44 from both sides and add 2x. So add 2x to both sides. And you're also going to subtract 44 from both sides. So that you have 0 equals x squared minus 18x plus, and this is 100 minus 44, so 10 minus 4 is 6, 9 minus 4 is 56. And then you can either factor or you can use the quadratic formula. In this case, I'm going to try to factor. So 9 times 6 is 56, but that doesn't help me out. But because 9 and 6, if added together, is 15, not 18. But 9 and 6 is 54, not 56. 8 and 7 is 56. But again, that doesn't give me 18. Let me see if there's anything. So 56 is 2 and 28, 2 and 14, 2, 7, 7 and 1. So I could do 14 and 4. See that? Because 14 times 4 is 56. And so x minus 4 times x minus 14 and x equals 4, x equals 14 are your solutions. So then you would have to substitute those values into your original equation to determine if you have any extraneous solutions.